Good afternoon, everyone. It is now 9 a.m. here on the East Coast in the U.S., and so we can go ahead and get started. My colleague Dina Rafe will also be on this call today, and she'll be monitoring the chat while we talk about the Artel MVS. If this is what you're interested in, please feel free to participate in the chat at any time, and she will get your questions answered as soon as possible. So we're going to go ahead and get started. We have a little bit of a slide presentation to go through with you this morning, or afternoon in your case, and then a little bit of a hands-on demonstration. So we'll go ahead and launch. You know that at this point with using Teams that you are able to put your comments in the chat and press enter to get those answered. So just a little bit of background to start. Nova Biomedical is the company that is currently owning and managing the Artel portfolio. Nova has been in business for about 70 years, and they now manage portfolios that specialize in critical care instruments, cell culture analysis, cell line development technology, and liquid handling quality assurance, which is what we are going to talk about today. So if we zoom in a little bit on the Artel product portfolio, we've been doing liquid volume measurement since about 1982. And here in the US, we are recognized as the global leader in liquid handling quality assurance. And we are using a patented dual dye ratiometric photometry technology. And we'll talk a little bit about what that means. It's a lot of words, I understand, but essentially if we make that a little bit more simple, we're using two dyes to measure absorbance and report a volume as it comes from each channel of a pipette or a multi-channel pipette or an automated liquid handler. Our goal for these products and services is really simple. We are trying to ensure that reliably you can say that volumes delivered from any type of instrument in any location are always the same. So standardizing volume delivery. So 2.5 microliters is always 2.5 microliters. We have a variety of systems and services that actually help you accomplish these goals. One of them is the Artel PCS, which is our flagship product. It's a single channel volume measurement device, which is really designed mostly for single channel pipettes and for measuring the performance of the people who operate pipettes. So as a pipette calibration or pipetting training tool. We also will be talking mostly about the Artel MVS today. Essentially what we've done here is take the technology that we use in the Artel PCS and put it into a plate format so that we can use it for multiple channels at a time. We also offer a series of services and trainings, one called the Artel or Automated Liquid Handling Service. That essentially gives you access to the information that comes from the Artel MVS with the benefit of one of our field service or field application scientists, where they come in and help you design a test plan for calibrating your liquid handlers. And then we also have a series of pipetting training classes, one being pipetting technique certification and the other being pipette quality management certification. We serve a variety of industries that range anywhere from diagnostics and clinical all the way to manufacturers and CROs and CMOs. But what is common throughout all of these industries is that everybody's trying to reliably dispense volumes. Some typical thoughts and concerns from our customers include things like, how do you select the right liquid handler for your job? All liquid handlers are not created equal, and some have specializations on what they do. Some are air displacement, some are positive displacement, some are acoustic, and you have to decide which is the best fit for your job. And the only way to do that is to have an objective measuring system that can tell you how those liquid handlers actually perform when they're doing the type of work that you need. Another question is, how can you directly compare robots throughout the lab? Very often, there are many different types of liquid handlers that are already existing in your lab. And to understand how they perform against one another is also very important, because you can't just assume that each liquid handler does exactly the same thing. Also, on the more negative side, how do you initiate troubleshooting? If you can see that there's a problem or your assay results are showing that there's a problem, how do you go about figuring out what the problem is? Do you have to always call the liquid handler manufacturer and get a PM or a service visit? With a standardized measurement method, you can do some of that troubleshooting yourself and keep your instruments up and running. So the real question is, what does volume really do to your everyday work? And so we wanted to model this, and we took a model assay and tried to vary the critical volume dispenses by plus or minus 1 or 2 microliters, just to see what the impact on the end result would be. So we had 3 different reagents that were critical to the assay: reagent 1, reagent 2, and the compound. And as I said, varied those by plus or minus 1 microliter or 2 microliters, and then carried that assay all the way through to the end and measured the IC50. At the end, you can see on the right-hand side of your screen on the lower portion that the variability in the measured IC50 was very large, despite the fact that only small variability was happening within the volumes that were delivered. So how can we fix all of these problems? Well, the answer is that, again, you need a standardized volume measurement method, and the Artel MVS can provide that for you. What you see up here on the screen now is an image of the package that you would buy. This system comes with a series of components that are all validated together: the plate reader, the label printer, the computer with system software, barcode reader, a mixer, and then the calibrator plate. And we'll talk about all of these little components and why they serve a very important purpose. There are also consumable pieces, which are the QualiSure solutions and the verification plates. Again, we'll talk a little bit more about how those are important. But first, let's talk about the technology. So the technology that I mentioned at the beginning of the slide presentation is a dual dye ratiometric photometry. And as I mentioned, that's really just a fancy way of saying that we're using 2 dyes and absorbents to measure a volume. And you may be very familiar with other absorbance-based approaches like tartrazine or fluorescein. But what is different about our approach is that we do have a second dye. And the purpose of that second dye is to measure the total volume in the well. If you think back to when you used tartrazine in the past, you probably dispensed water on top of your sample to dilute it. And you needed to know exactly how much water you were dispensing. In our case, because we have a dye there to measure, and it is also present in the red dye solution at the same concentration, we're actually able to use that as a non-quantitative addition to measure the total path length in the well. The red dye serves as our sample, and the sample will vary according to the volume that you're trying to dispense, or your target volume. So again, your target volume will be red. You will backfill with this blue dye solution that we use to measure total volume in the well. We mix those together and then take absorbance readings and compare those to the known absorbances of the dyes at the start. To do that, we will measure the absorbance at 520 nanometers and 730 nanometers. This whole process, despite the fact that I've taken a while to describe it, only takes a couple of minutes to do. So I mentioned that there are other key components to this calculation, and one of them is what's happening in the microplate. So we call these verification plates, and the reason for that is because we put a lot of work into these plates to characterize how they perform and then mitigate variability. So as we know from COVID, injection molded plastic parts are not all the same, and some have more variability than others. So what we've done with our verification plates is measure them on a lot by lot basis and determine the taper angle of the sidewalls of the wells and the bottom diameter. And that information, along with how each well performs in relation to its neighbor, is all encoded on the barcode on the side of the plate. We're able to remove the variability that comes from the plastic part by doing all of this characterization, and then that doesn't contribute variability to your final measurement. Another very key component to this calculation routine is the Qualisure solutions and the diluent solution, and those are the dyes that I was talking about a few moments ago. We have the red dye solutions that I was mentioning. Those are your samples, and they do vary in concentration. And the reason for that is that the absorbance just has a very small dynamic range. So in order to accommodate a very wide range of volumes or target volumes that you're trying to measure, we need different concentrations of dye. So for larger volumes, you'll use a more dilute solution, and for smaller volumes, you'll use a more concentrated solution. And no worries, the software will walk you through each one of those steps so you do everything correctly. The system itself will measure volumes anywhere between 10 nanoliters and 350 microliters directly, and for volumes over 350 microliters, we have a multi-dispense approach. You can see in the bottom left-hand side of your screen, the absorbance scan that you're seeing here shows the different concentrations of the red dye solution at the 520 nanometer mark, and then a constant absorbance at 730 nanometers. That's the blue dye solution I was talking about. So as I said, it is present in all of the red dyes as well, which is very important when we start to add the diluent solution or the pure blue dye solution. As you can see on the right-hand side of your screen, the absorbance at 730 nanometers of that diluent solution is exactly the same as it is in all of the red dye solutions. So we're never diluting that, and we're able to use it as a reference. Most of the dyes that we sell are aqueous in makeup, but it's also important to understand that there are two questions you can answer with the MVS. One, is my liquid handler working according to manufacturer's specifications? And two, is my liquid handler working for what I use every day, which is may or may not be an aqueous dispense. In the case that you are dispensing something other than aqueous, we have a series of dye solutions that have different makeups. One of them is a DMSO solution, another pipettes like PCR master mix, and we call that PCR mix. It has a surfactant component as well as a viscosity component, and then also a serum-like solution and a plasma-like solution. Another key component to this routine is the calibrator plate. We are trying to mitigate all sources of variability in this measurement, and one of them comes from the plate reader. The calibrator plate takes care of that. So it contains a series of filled cuvettes, as you can see on the right-hand side, and those span the absorbance range of all of our solutions. It also contains a blank type vial and an unchanging standard, which allows it to make sure that the calibrator plate is stable over time. When you run this calibrator plate on the plate reader on the day of test, it corrects the performance of that plate reader to read exactly the same as the NIST traceable spectrophotometer here in our reference laboratory. So if you have 5 Artel MVS solutions in 5 different locations, you can be confident that they're all reading exactly the same. The steps to running the Artel MVS are very simple. You'll dispense your red dye solution, which is your sample, from your liquid handler that you're trying to test. And then you'll backfill those wells to a total volume of either 200 microliters in a 96 well plate or 55 microliters in a 384 well plate. These steps are also interchangeable. So if you normally use the liquid handler to dispense critical volumes into a well that already contains solution or a wet dispense, you can put the blue dye in first, so it mimics what you're actually doing. If you normally dispense into a dry plate, you'd put the red dye in first. Once the two are there, you mix the two together on the included plate shaker to make sure that the solutions are homogeneous, and then you read the plate. The results are automatically calculated for you and report accuracy and precision information for every channel that you have dispensed from. For those of you who are concerned with compliance, the Artel method is mentioned in the ISO 23783 standard for liquid handlers. And then also our methods are compliant with ISO 8655, and all of your results will be fully traceable to NIST. We will go over the software a little bit more on the hands-on piece of this demo, but the ArtelWare software is sort of the brains behind all of the different components that I just showed to you. It does have a nice dashboard feature that we'll go over and a customizable home screen. As a result of the test that you'll be performing with the Artel MVS, you will end up with the report that's shown on the right-hand side of your screen. The reports are also customizable with your specific company information. And then you are able to also print labels that show that the instrument that you are testing has been calibrated. And finally, from the software, you are able to also export your entire inventory of your liquid handlers or multi-channel pipettes, depending on how you'll be using the Artel MVS going forward. All of the reports and these inventory lists are able to be exported in Excel or PDF. So just to round out this part of the presentation, the slides piece anyway, why would you choose the Artel MVS? I mentioned earlier that there are other methods for measuring volumes that are dispensed by liquid handlers or multi-channel pipettes. I talked about single die methods, but certainly everybody's also familiar with a gravimetric method, or weighing your plate. And I wanted to point out that there are lots of different sources of variability in all of these methods. The liquid handler itself, of course, the reagents that you're using, if you're using a dye-based approach or a fluorescent approach, the tips that you're using, the temperature in your lab and the operator. And then from a more technical perspective, the mixing is important, the detector you're using is important, and the plate type is important. So what we've done with the Artel MVS is take all of those sources of variability and remove them from the calculation. So what you're left with is just measuring how variable is your liquid handler and the tip combination, which is the information that you're trying to find. So at this point, I'm going to stop doing the PowerPoint part of the presentation. I will shut off my camera and my share for just a moment, and I will be right back with you as I set up for the hands-on piece of the demonstration. All right, so I'm going to switch the camera now to look at the Artel MVS, and you should be able to also see the software up here on the screen. So I will go over the software a little bit, and then we'll do a little bit of pipetting. So as I mentioned during the slide presentation, the software has a nice little get started bar up here at the top to guide you through the process of getting your Artel MVS set up. And a couple of these steps that I will be showing you are one-time steps just to get the software oriented for what you'll be doing with it, but I do want to show you how all of that goes. So you are able to add specific users. If you would like to have different users have different permissions, you're able to do that within the software. If you have multiple locations where your liquid handlers are located, you can assign locations to each one of those liquid handlers, as well as owners. This software also runs our system that does single channel pipette calibrations. So you are able to use the same software for both platforms, and that would be what you would be doing under adding an instrument. For adding a device, we are going to actually start here, and these devices will be the types of liquid handlers or pipettes that you'll be calibrating. So if we select liquid handler for our purposes today, You are able to pick from a series of different manufacturers, and this should cover almost everything that is on the market. But if it doesn't, you always have the ability to also add your own. But you'll be selecting from a drop-down menu of several different manufacturers, as you can see here, and most of their different platforms are also listed down below here in the model. So once you select one of those, and we'll pick Bravo for the sake of conversation today, you are then able to add a liquid handling ID, and that can be whatever you call your liquid handlers in the lab. Today we'll just give it a number. You're able to add a description and serial number, and then as I mentioned, you can identify the location and the owner of your liquid handler. Under dispense heads, then you're able to add the type of heads that are attached to your liquid handler. And perhaps you have more than one, and you are able to also add more than one to each one of the platforms. So for instance, with this Bravo, if you had an 8-channel dispenser and a 96-channel dispenser, you're able to add both of those under the same platform. So let's say it was an 8-channel today, and you'll select from the drop-down menu here. And what you'll see on the drop-down menu is everything that's appropriate for this type of platform. So it will go anywhere from 1 to 384 channels. You're able to add your serial number and description, and then you'll just click OK, and it will add your head to this platform. When you click OK, it will commit it to the database and save as well. Now, if we go back to the home screen, and again, that's a one-time setup. Once you have all of your liquid handlers or pipettes in the software, those will be there to stay unless you retire them. The next step is to create a test plan. So if we click on creating a plan, again, this is the software that runs both our single and multi-channel devices. So you can pick either pipette or liquid handler calibration. And then also you'll see an option for operator assessment. And that's because this software also includes a module that allows you to use it as a training tool for people operating pipettes or liquid handlers. Now, as we design our test plan, it does need to have a name. Give it the date. And then we're going to pick the plate type that we're going to be dispensing in. And if you click on this drop-down menu, you'll see that there is an option for either 96 or 384 wells. Here is where you're going to select the number of channels again to marry that test plan to the type of device that you're actually going to be testing. So you'll see the same drop-down menu here as what you saw before, minus the 384 option, because of course we've picked a 96 well plate. You'll decide on your orientation and tip spacing, and then if you'd like to identify a liquid class name, you can do that here. On the right-hand side, you can decide how you would like to see the output or the results. You can either decide if you'd like to see channel statistics, dispense order statistics, or both. And then you can also report these as absolute values instead of percents if you would prefer. Under dispense steps, now we're going to tell the software exactly what we want to dispense and where we're going to be putting it. So in the case of today, maybe we would like to put 20 microliters in part of the plate, maybe half of the plate. So we'll select 6 replicates because again, we have an 8-channel device in a 96 well plate. You're able to identify the accuracy and imprecision tolerances yourself. So let's say we wanted 5% for inaccuracy and 3% for precision. And then you can just pick your favorite color from the menu here and click dispense step. And now you're going to tell the software exactly where in the plate you'd like to be putting your first set of samples. Because I'd like to fill the first half of the plate, I will color the first half. And now you can see that each one of these wells has a number in it, and that indicates what dispense number it corresponds to. So we'll be dispensing in column 1 for our first dispense, column 2 for the second, and so on. Now, if we'd like to fill the second half of the plate with a different volume, we can certainly do that by just reporting the same steps over again. So here we'll select another 6, and you can identify different pass or fail tolerances for your second group. You'll pick another color. Actually, let's pick red. And you'll highlight the area of the plate that you would like to dispense your second volume in. So now you've got a plate map that corresponds to the tests that you'd like to do to prove the accuracy and precision of the liquid handler under test. When you click Approve, it will save it to the database, and now you can see that it ends up in the list of different things that I can choose from. If we go back to the home screen again, you're also able to create a schedule for all of these types of devices that you'll be calibrating. And in a client-server installation situation, you're able to receive email reminders when those devices are due for calibration. So now we're going to go ahead and start verifying a liquid handler. And today I'll be using a pipette. It's an 8-channel device, but you can imagine if this was an 8-channel liquid handler. You can either pick a scheduled liquid handler verification or an ad hoc, which is what we'll be doing today. All right, so we do have a 200 microliter variable pipette. You can see that I have that set up here, and I will be dispensing 50 microliters into half of the plate and 150 microliters into the other half of the plate. And you can see that each of these has different tolerances set up. So when I click Start Verification and select the instrument that I'll be using, now it is going to walk me through every step of what I need to do. This is a very easy to use system that you'll be seeing here. So it tells me that I need to scan the appropriate bottle of the QualiSure solution, which will be the range A solution. And then the next step, it will ask me to scan the appropriate diluent bottle, which I will do. And then it's going to ask me to scan one of our verification plates. So I have that here. And now it tells me exactly what I need to put in the plate in order to accomplish this test plan. So you can see that I need 50 microliters of the range A solution on the teal colored side and 150 of diluent, and then 150 microliters of the range A solution and 50 microliters of diluent on the purple side. So I will go ahead and do that. And you can judge my pipetting while we go through this task. But what I'm also going to do is on purpose, I will not dispense into one of the wells so that we can see what would happen when something fails. Again, if you have questions, please make sure that you're putting them in the chat. Now, I did select 2 volumes today that use the same type of QualiSure solution. And that doesn't mean that you always have to put the same type of QualiSure solution in an entire plate. Those can vary depending on the target volume that you're trying to dispense. So for instance, if I had a much smaller volume than the types that I'm trying to dispense today, it would ask me for something other than the range A solution. Perhaps it might be the range E solution, and it can accommodate both. You can also pick more than or less than 6 replicates, of course. I've tried to make things easy today for the sake of our demonstration, but you can do just 3 replicates or maybe even 1 if you're just trying to do a quick check. Many times people will be using this system not just for calibration of a device, but also quick checking in between those calibration events. So maybe you have less data points that you're collecting for the quick checks and more points that you're collecting during those full calibration runs that maybe only happen a couple of times a year. So the next step is adding this blue diluent solution. I'm trying to get to a working volume in each one of these wells of about 200 microliters. Remember, I said that this is a non-quantitative addition, so I'm not really that worried about the accuracy or precision. I'm using the same pipette that I used for the sample solution or the red dye solution, but you don't have to. You can use a bulk dispenser or a different pipette. It doesn't really matter how you get that blue dye solution into the plate as long as it's there in order to, again, dilute the sample solution and get to that working volume. So for the first half of the plate, I put the 150 microliters of diluent in there. And now I'm putting 50 microliters of diluent. And you'll remember that I said that I wanted to not dispense everything into one of these wells. So I'm going to go ahead and just take out a little bit. All right. So now we have two sides of the plate that have been dispensed. You can see that one is a little bit lighter in color and one is darker as a result of the more volume or a higher concentration of the red dye solution in the plate. So as I'm following the directions on the screen of the software, I have filled the plate now, and it's time to attach it to the shaker and shake the plate so that the two dyes are completely homogeneous in the well. You can imagine if we didn't have complete shaking or complete mixing, that we may end up with some dye pockets within the well. And if the light doesn't hit those, or even does hit those, you can end up with skewed results. So this mixing step is very important. And that actually points out another place where the Artel MVS can be used. If you have a mixing protocol within your liquid handling methods, and you'd like to decide if that mixing is complete, you are actually able to mimic that using the Artel solutions and measuring before and after the mixing protocol using the MVS and determine if the results are consistent. If they are not consistent, then you know that your mixing is incomplete. So that points out that it's not just a volume measurement tool, but also a tool to measure the performance of specific applications within your liquid handling protocols. So now we'll start the reading. It's going to measure each one of these wells, first at 520 nanometers, and second at 730 nanometers. And if you recall the equation that was up on the screen back at the very beginning of this presentation, it's going to use the ratio of those along with the known absorbances we've fed into the software through the barcode scanning to calculate the volume in each one of the wells. The process of reading the plate for a 96 well plate takes a little over a minute, and for a 3D 4 well plate takes about a minute and a half. So you can imagine that all together with the shaking, each one of these plate measurements is going to take about 2.5 to 3 minutes, despite or regardless of the type of plate that you're using. Right, so once those all the wells have been read, we will realign our focus to the software screen and take a look at the report. So you'll notice that up here at the top, we've got a title that says ArtelWare Liquid Handler Verification Report. And that is, again, customizable. You can change that to be whatever you'd like it to read. And then we've got some some information about the test itself, what head we were dispensing with, what type of dispenser it is, an 8-channel, the orientation, the dates, the times, the owner, and the location, and then we'll get into the very specific pieces of this report. So you'll remember that I had 2 groups of volumes that were being dispensed, 50 microliters and 150 microliters. So at first we'll take a look at the 50 microliter section. You can see that it's got a target volume listed here, the number of replicates, the type of solution, and how it was mixed together. Then we'll take a look at the average information. So our target again was 50, but our mean was 50.478. It's got standard deviation, uncertainty, inaccuracy versus the tolerance, and imprecision versus the tolerance. So you can see that these are well within the pass or fail tolerances on average, and so we end up with a passed result. Now, I hope you noticed up at the top of this report, it does say failed, so we'll find out where that failure was, and I'm sure that you can assume that it's where I took some of that solution out during the dispensing routine. So back to the 50 microliters for a moment. Now we've got channel statistics. You'll remember that I had an 8-channel device that I was measuring with, trying to measure. So each one of the channels is individually assessed with the number of replicates, mean, standard deviation, inaccuracy, and imprecision. And the pass or fail, again, is comparing to the tolerances that you set. If you're interested in taking a look at the dispense order, now you can remember that we did 6 replicates. And so each one of the individual dispenses of all 8 channels is also assessed with statistics. This is important if you have a multi-dispense routine where you're aspirating a large amount of solution and then dispensing several times across a plate. Very often, your first dispense or your last dispense looks a little different than the rest. With something like this report, you're able to identify what those trends may look like. And then at the very end of this section of the report, we have sort of a bird's eye view of what the plate looks like and the volumes that are dispensed within it. If we had anything that was failing, it would be flagged, and you'll be able to take a look at that here. So again, our second section of the plate had a target volume of 150 microliters. And this is really important here because you can imagine if you were using something that doesn't report each individual channel or each individual well of information, the mean here would be passing. It is very close to the 150 microliter target. And without being able to see what's happening in each individual well, you have no idea. You would be passing and moving on to your next step. But if you take a look at the precision here, you can see that it is actually outside of the tolerance. And that is because of that one well that was mispipetted. So again, we've got channel statistics, and that one channel, channel 8, is the one that has a volume that is outside of tolerance, and that is throwing everything off for that channel for the rest of the section. However, going back to those averages again, the dispense order shows that while there is something that is a little off on that 6th dispense, the averages still work out okay. So this is pointing toward why it's important to have all that individual information. And here you can see that's the well, that's the suspect well where I took some of the solution out, and it is showing up in that bird's eye view. Down at the bottom of the report, you've got a materials list with lots and serial numbers and expiration dates, where they were used within the plate. And then information specifically about the MVS instrument itself. And you do have the ability to apply electronic signatures to the reports before they are exported, again, in either Word, Excel, or PDF format. I'll go back up here to the top And again, let you know that you can put any of your questions into the chat, but this concludes the demonstration. So if you do come up with questions that you wish you had been able to ask or you thought to ask during the presentation, please reach out to your account manager with Nova Biomedical. We'll be happy to help you with any of those questions. And we'll also have a recording of this demonstration that we can provide to you after. Thank you all so much for your time. I really appreciate it, and I hope you have a great evening. Take care.